Welcome to the project demonstration of solar operated thermoelectric plate refrigerator cum oven system. So in this project the main modules are like Peltier plates. So this is the inside this we have mounted the Peltier plate, that's thermoelectric plates, so which can take power supply and provide the heat one side and another side cooling. Okay, and next that will be monitored by this DS18B20 temperature sensor, and that was interfaced to our PIC microcontroller. So the whole system driven by the power supply of 12 volts 2 amps. So in these two battery packs are connected in parallel. Each battery pack consists of 3 4 volt 1 amp batteries are in series. So we will get 12 volt 1 amp and 12 volt 1 amp, so that we will get 12 volts 2 amps, so which is rechargeable battery. So to recharge this battery we have two sources. One is a grid, nothing but SMPS supply, and another is for solar panel. So this is the main charging circuits. So just connecting the T to the T or S slots, and by providing the 230 volts input to this cable we can charge a battery. So this will take around 8 to 10 hours to be fully charged from this transformer. At the same time, if you want to charge a battery from the solar panel also, it will take maximum of 10 hours. So during the time it will be charged, and after that you can disconnect the grid power supply or SMPS and then connect the solar panel S to the same slot. By disconnecting the transformer, you can connect the solar panel. So when we place this under the sunlight, it will generate the voltage up to 14.5, which is sufficient to charge our 12 volts 2 amps battery. Coming to the charging circuits, so there the 4 diodes are connected in a bridge rectifier manner, so that we will get pulsating DC when we provide the transformer inputs. But when we connect the solar panel, these 4 diodes will not work as a rectifier. This normally short circuits. So from solar panel to the capacitor, and the capacitor is for just only for smoothing purpose. And after that, with the help of these 2 diodes, there are the 2 diodes, we can see that. So with the help of these 2 diodes, the power will be given to the batteries. So right. So these 2 diodes purpose is whenever the battery is fully charged and if there is no sunlight, then this will become the high potential and the solar will become the low potential. And then in order to stop the opposite current flow from the battery to the solar panel, we are going to making use of these 2 diodes in reverse bias, so that only power current will be flow from the transformer solar panel to the battery. So for the solar panel and the grid protection purpose, we are making use of this 2 diodes. So here the diode ratings are IN4007 and capacitor ratings are 1000 microfarad 25 volts. And this solar panel is placed under the tube lights, so we'll get the low intensity LED indication for this kind of intensity of light. And once the battery is fully charged, this is the main on-off switch which will provide the power supply to the kit as well as to our Peltier plates through this buck converter. So this will take 12 volts inputs and provide us the 5 volts constant output, so which is main sufficient voltage for our microcontroller and the Peltier plate. So the Peltier will work under the 5 volts, and we are going to set the temperature inbuilt in programming microcontroller, that is for 25 degrees centigrade. Whenever the temperature is below 25 degrees centigrade, the system will switch off this power supply to the Peltier plates with the help of this electromagnetic relay, and so-called status continuously displayed on the LCD screen. And if it is above 25 degrees centigrade, then system will allow the power supply to the Peltier plates. And this is one switch is there. So the main purpose of this switch is we can use heating purpose and cooling purpose. So middle is on. So you can see that there we can develop already. This is H, heat purpose, and C for cool purpose. Middle is off. So always keep this in middle if you didn't use the execution of this project. So now let us see the demonstration directly. Right. So just switch on the switch. So welcome message will be displayed on the LCD screen, and the relay got switched on as the temperature is normal. So when I switch on this cooling purpose, so underneath you can see the green LED indication. When it is heating purpose, red light. So I'm doing for cooling. So when you're switching between the cooling and heating, you should provide at least of 30 seconds time to let the Peltier plate should be cooled down. So you can see the temperature is decreasing. previous is 34.1. So as we are using this buck converter, so that the current will be limited, if we provide the maximum voltage to the peltier plate, it may burn out, or else the circuit will not work properly. So for that purpose, we are making use of this LM2576 buck converter regulator IC. So you can see how rapidly the temperature is decreasing. So now just switching off that, you can sense the cooling also on the surface of this plate. Let the plate come to the normal temperature, the room temperature. Turn off after 30 seconds. You can switch on the heater. So again, the temperature also increases gradually when we switch on the oven section. Coming to the refrigeration section, it will decrease the temperature rapidly and increase temperature. Right. So coming to this motherboard, so we have interfaced the PIC microcontroller with crystal oscillator and reset switch. So this is the reset switch to restart the microcontroller. So only it will restart the controller, no program will be erased. And the main purpose of this steel plated crystal oscillator is to provide the clock pulse to the microcontroller. So that will be around 20 megahertz. The main purpose of the oscillator is, so based on the clock pulse, the system will execute the instructions. So per instruction it will take one clock pulse. So we are providing 20 mega clock pulses per second. So that controller will execute 20 mega instructions per second. Right.